Okay, dear student, let's see what is there. In this question, a coil of wire rotates at a constant angular speed omega in uniform magnetic field. The variation with time for the EMF of the coil is given. The angular speed is changed to this. What is the amplitude of the EMF and the time period? Very good. Again, this is a very important topic, very important formula that we are going to use. And also, this question is not the first time that IB is asking. It has been asked many times earlier. Sometimes the omega becomes half, sometimes the omega becomes double. In this case, omega is becoming 0.75 times, isn't it? So essentially, it is the same question, and you might find similar questions on my YouTube channel. Already, you can just check the playlist and you can find so many questions based on the same concept. So, which clearly means this concept it becomes immensely important for us. We cannot miss understanding this. Okay. Now, so there is this formula of the EMF, and that is given by NBA omega sine omega t. This is the formula for the EMF. And that can be derived very easily if you go for the derivation for the rotations of the coil and all. This is in the topic D4. Let me see if the formula is given there. Well, the formula is not present in the D4 or in the data booklet. So you have to note this formula. And how do you derive it? Like all the lectures are there on YouTube channel. You can watch them, by the way. So the flux is B into A cos omega t, and then you differentiate it. So EMF is equal to d phi by dt negative. So this comes out to be NBA omega sine omega t. And from there, we are getting this formula, by the way, in short. So omega is coming twice in this equation at two different locations. Now, this omega is related with the time period. So omega is equal to 2 pi by capital T. So if something happens to omega, you can just find what is going to happen to the time. So if omega is double, the time becomes half. If omega is half, the time becomes double. Now in this case, the omega is multiplied by 3 by 4. So time is multiplied by 4 by 3. So first of all, the time period will be multiplied by 4 by 3. That will be the new time period. And that comes from this, that omega is equal to this. So if omega is changing, then the time period will also change. Simple ratios, you can just do the algorithm, the algebra. And so accordingly, you will find the value 4 by 3 t. Now, omega is coming at the second place also, which is exactly in the amplitude of the EMF. So the amplitude of the EMF is directly proportional to omega. Now omega is multiplied by 3 by 4, which means that the EMF is directly multiplied by 3 by 4. It means that your amplitude is also becoming 3 by 4 times. So amplitude will be 3 by 4 times the earlier one. Earlier it was 10, so you multiply 10 here. So overall it is kind of 7.5, 30, 15, yeah, 7.5 volt. And the time period is 4 by 3. The time period here, okay, now that is a twist. So we have to find the time period value. 1, 2, 3, 4, 5. So in 4 milliseconds, again, be very careful about the multiplier in the unit. 4 millisecond, 1, 2, 3, 4, 5, 5 oscillations. So one oscillation is having 4 by 5 millisecond time period. So it will be 4 by 3 into 4 by 5 milli. So we are going to find this value there. So one moment, please. Yes, I'm getting the value as 1 milli. So time period will be 1 millisecond approximately. And this value is 7.5. Let us see if there is any option that talks like this. 7.5 and 1.1. Absolutely correct. So D will be the right answer. And this is how we do it. So this formula has been asked time and again by IB. You can even write it in your notebooks there. E is equal to NBA omega sine omega t, where N is the number of coils, B is the magnetic field intensity, A is the area of the coil, and omega is the angular velocity with which the coil is rotating. So this is the formula we are going to use. This is very important topic. Okay, dear students, so all the best. This is Professor Varun. Thanks for joining. Okay, let us first verify the answer. After that, there will be a buy. And this is question number 31. And yes, the answer is D. And this is how we do it. Okay, then, all the best. Bye.